Okay, what we're going to do today is continue on with solving systems of equations, but this time we're going to use a different method called elimination. Previously we covered solving systems of equations using substitution. Today we're going to use what's called elimination. So let me zoom out there. Here's the format with Cornell style notes. Space for your summary. Solving systems using elimination. Alright, so as usual, we're going to begin with our prior knowledge. Prior knowledge, of course, remembering how systems of equations work. So if you have any questions on what we're doing with the general feeling of systems of equations, we go back to the previous video. But remember that a system of equations is when we have two or more equations on the same coordinate plane, on the same graph. We need to remember that the solution for a system of equations is that point where the two graphs cross. In some cases more than two, but that's for later. So the solution is the point where they cross, and that's the basics. Anything other than that that you still need a refresher on, we'll go back to the previous video. We also need to remember combining like terms, because things get a little interesting with elimination regarding combining like terms. So here's an example. If we have 2x minus 7x, that's going to equal negative 5x. We have 2 x's, take away 7 x's, we end up with negative 5 x's. Okay, so remember combining like terms. We also need to remember the additive inverse property. So if you've forgotten what that means, that basically means any number plus its inverse is going to be equal to 0. So for example, if I have the number 5y, I add to it its opposite, negative 5y. If I add those two, 5 and negative 5y, 5y, negative 5y, it equals 0. That's the additive inverse property. Same token, if I had 7x, take away 7x, I get 0. Same token, if I have a negative 13y, I add to it a 13y, the opposite added equals 0. So that is the additive inverse property. Doesn't matter what the x is, doesn't matter what the y, any number, variable, anything plus its opposite is going to equal 0. I also need to remember the additive identity property. So this property states any number plus 0 doesn't affect the number. So if I have this equation, we'll start with this equation. If I had 0 plus 3y equals 9, that's an equation. It's simply the same thing as good old 3y equals 9. Okay? The fact that I have 0 plus doesn't matter. It doesn't affect it. That's the additive identity property. Adding 0 or subtracting 0 does not affect the number. Here's another example where things get a little tricky because we're kind of sloppy with signs sometimes. If I have 0 minus 3y equals 12, the 0 doesn't need to be there. It's just negative 3y equals 12. We just have to be careful with the sign. This negative belongs to this 3. Okay, so the 0 doesn't take that away. The negative belongs to a 3, so it's negative 3y. The 0 doesn't take that away. So that's all prior knowledge we need to be good with to make elimination a little easier. So what we're going to do is take a refresher course on systems of equations. So let's refresh our memory how that works real quick. First we find the value of one of the variables. Then we plug that value into the other equation. Then we find the value of the other variable. List the answer as an ordered pair. Okay, so all that was in the previous video. We moved a little slowly on there. So previously, we learned to use substitution to solve the systems of equations. Today we're going to learn about using elimination. Alright, so here's kind of the new stuff. Okay? You can add or subtract entire equations. That's a handy piece of knowledge to take with you, that you can add or subtract entire equations. For elimination to work, what you can do is add or subtract an entire equation so that one of the variables cancels to 0. So you can add an equation, as long as you're adding the opposite of one of the variables, you're going to get 0. Or you can subtract equations, and you can cancel one of the variables so that they subtract to 0. The whole thing works that way. Once a variable cancels, you solve for the remaining variable, and you've completed step 1 from the process. Okay, so with step 1 in elimination, we can do it by adding or subtracting entire equations so that a variable cancels completely, and then we can continue on the process to find the value of the variables. So let's get into examples, and I'll show you what we're talking about. So if I start with a first example with a system of equations that should be a little bit easy to handle. If we have 2x plus 3y equals 7, and we have another equation, negative 2x minus 4y equals negative 4. Okay, so again, this is a system of equations. Two different equations working on a coordinate plane. Can we add or subtract these two equations entirely? Okay, so remember that's the note. We can totally do that. We can add the entire equations. The way that works is that we want our variables lined up. As long as I have an x over an x, a y over a y, an equal sign over an equal sign, we can add those two equations entirely. All we have to do is add them straight down. So hopefully with this you can see that if you add the two equations, if you add straight down, you have a 2x and a negative 2x. And when you add them together, remember what that equals? 0. The x cancels completely. You have to be able to see that in order to be good at elimination. So hopefully you can see that if you add these two equations, we're going to cancel that variable. So I'm going to go ahead and do that. And when I add equations, I'm going to put a big old plus sign out to the side to remind myself that I am adding these two equations. So here's what happens. I add straight down. 2x plus negative 2x. What is that going to give me? 0. Remember, the variable cancels completely. I'm going to add straight down. 3y plus negative 4y. So 3y plus negative 4y gives me a negative 1y. My equal sign stays there. And then I have 7 plus negative 4. And 7 plus negative 4 gives me negative 3. So we have added the two equations entirely to get another equation. That is a legal thing that we can do. We can add those two equations entirely. All we have to do now is clean this mess up. Let's clean it up. 0 minus 1y, well, the 0 doesn't need to be there. So we have a negative 1y equals negative 3, and now we're ready to solve for y. So can you see how easy it will be now to solve for y? So let's solve for y. Divide both sides by negative 1. Y equals negative over negative is positive 3. Okay? So we have just completed step 2 and 3, or excuse me, step 1 and step 2 of our systems of equations. We found the value of one variable, and we're able now to plug it back into the other equation. The way we did it is by adding two equations entirely. So we can add equations or subtract equations entirely and cancel a variable. Now, if you remember, what do we have to do? Plug that value into an original equation. So we can pick either original equation. Doesn't matter. And I'm going to pick the first one. So if we start with 2x plus 3y equals 7, we know that y equals 3. We can substitute that value. So no longer 3y, it's 3 times 3. So we're continuing where we left off from yesterday. Now we solve for x. Here I'll move a little bit quicker. So 3 times 3 is 9, and that's going to equal 7. I subtract 9 on both sides. And then I divide both sides by 2. And when I divide both sides by 2, negative 2 divided by 2 gives me negative 1. So I have now found the value of both variables. And if anything we did from this point on is confusing to you, go back to the other video on solving systems of equations using substitution, and you'll see how I'm doing this a little bit quicker. And so now we have our two values. We have an x value and a y value, and remember we list it as an ordered pair. The x value is -1, the y value is 3. There is the ordered pair where the two lines cross. So let's revisit the process of what happened. Okay, so here's the process. We started with the original system of equations. We were able to recognize that if we added these two equations, the x variable would cancel to 0. So that's what we did. We added the two equations, and we canceled the variable of x. We were able to clean things up and solve for y quite easily. Once we solve for y quite easily, we continue with the process from the previous lesson, plugging that back into one of the original equations, and then finding out what the value of x is. And that gives us our x-coordinate and y-coordinate for where the two lines cross. So let's do another example. So in the next example, let's say we have 2x plus 4y equals 22. Let's say we have negative 2x plus 2y equals 8. And I'm going to move pretty quickly through this because it's pretty much the same process as the previous example. We have to be able to recognize that if we add these two equations, everything is lined up. X's over x's, y's over y's, equal sign over equal sign. Everything is lined up. All we have to do is add straight down, and the x will cancel. So we need to recognize that. So we add straight down, and the x's will cancel. 2x plus negative 2x is 0. 4y plus positive 2y is positive 6y. And 22 plus 8 is 30. So the x completely cancels, which is what we want. It has been eliminated. That's why we call it elimination process. Now we clean up our leftover equation and simply solve for y. To solve for y, all we do is divide both sides by 6. We have y equaling 5. We take that value of y and put it back into either of the original equations. I'm going to use the top original equation. 2x plus 4y equals 22. And then I'm going to substitute my value for y. 2x plus 4, not y, 4 times 5. And that's going to equal 22. And now I'm ready to solve for x. 4 times 5 is 20. And now I will subtract 20 on both sides. And now I will divide both sides by 2. So x would equal 1. So I've been able to solve my equations, find out what the value for x and y is, and now I list it as an ordered pair. The x-coordinate is 1, the y-coordinate is 5. And there is the ordered pair where the two lines cross. And that is my second example. Let's go into a different example so we can see how subtraction works, because that gets, actually I'll cancel out another variable. I will get to subtraction later. But let's do another example. We have 5x minus y equals 0, that's one equation. 3x plus y equals 24, that's my second equation. Can we eliminate a variable by adding or subtracting these entire equations? If we added them, would the x cancel? No. If we added them, would the y cancel? Yes. If we add these two equations, negative y plus y is 0. Remember the additive inverse property? That would cancel. So if we add these two equations, our y is eliminated, and we want that. So let's add these two equations. You have to be able to recognize that this is what's going to occur. So now I have 5x plus 3x gives me 8x. Negative y plus positive y cancels completely to 0. And 0 plus 24 is 24. The y cancels completely. All we have to do, clean up the mess. Let's clean this up. The plus 0 is not needed. That's the additive identity property. Now all we have to do is solve for x. We would divide both sides by 8. X equals 3. What do we do with that x equals 3? Plug it back into one of the original equations. Plug it back into one of the original equations. So one of the original equations is 5x minus y equals 0. But I know that x equals 3. I will substitute, not 5x, 5 times 3 minus y equals 0. So I'm plugging it back into original equation. I'm going to solve for y. First thing I need to do is multiply. And now I have to get y by itself. Let's see if you can guess what I'm about to do next. I'm going to show my work this time because a lot of students are sloppy with the equal sign. The equal sign must always stay there. So I'm going to show my work this time to see how I get this. Most students on this example will get it incorrect because of a sign. And now I have negative y equals negative 15. If negative y equals negative 15, what would positive y equal? Positive y would be positive 15. So I have my x value at 3, my y value at 15. Ordered pair. That's where they cross. So let's do more examples. I'm going to do another example. Now this next example is where we get subtraction coming in. So I'll have two equations. And when you see two equations, you have to ask, if you can't use substitution, x is not by itself, y is not by itself, can we use elimination? Can we add straight down so that a variable will cancel? If we add straight down, will the two x's cancel? No. 2 plus 2 is 4. That wouldn't cancel. Would the y's cancel? No. 3 and 10 is 13. What if we subtracted straight down? 2x minus 2x. That's 0. That would cancel. So we can subtract straight down. And when I'm going to use subtraction, I'm going to put the big old minus sign there so I can remember that's what I'm doing. Okay, so now I just work out loud. I have 2x minus 2x, 0. 3y minus 10y, negative 7y. And then 9 minus 16, negative 7. So my x cancels out completely. Now I'm ready to clean up my mess. Negative 7y equals negative 7. Lastly, divide both sides by negative 7. Y equals positive 1. So I've used subtraction this time, and now I have my y value. Plug that back into one of the original equations. I have an original equation of 2x plus 3y equals 9. But I know that y equals 1. So I'm going to substitute my value of 1 for y. So 2x times 3 times 1 will equal 9. And so I have 2x plus 3, because 3 times 1 is 3, equaling 9. I'm ready to undo my equation. I will subtract 3 on both sides, and then divide both sides by 2. So I have isolated my x. I have previously found the value of y, and now I have my x coordinate and my y coordinate. I list the answer as an ordered pair, because I understand that the solution to a system of equations is a point on the graph where the two lines cross. So now I'm going to show you one more example that's very, very tricky. This is going to require a lot of thinking. And before I do that, I'm going to show you a note a note that reads, "What to do if nothing cancels?" If nothing can cancel on the first try of adding or subtracting, what we can do is try multiplying one of the equations by a number that would let them cancel. So this is going to require thinking. We can multiply an equation by a number that would allow elimination. So let me show you an example of what I'm talking about. If I have a system of equations that looks like this, 2x plus 3y equals 9, and x plus 5y equals 8, can I use elimination for either of these variables to cancel? If I add straight down, my x's won't cancel. If I add straight down, my y's won't cancel. If I subtract straight down, 2x minus x does not cancel. If I subtract straight down, 3y minus 5y does not cancel. So I can't use elimination yet. But remember that previous note. Can I think of a number that we could multiply one of these equations by that would allow cancellation? I have to think of a what-if scenario. What if instead of this x being here, we had a 2x here? If we had a 2x here, couldn't we subtract the equations? Yes, we could. So we have to think that. What if there was a 2x here? Now what we have to do is consider how in the world do we get that to be a 2x? So what we do is multiply that entire equation by 2, both sides. We can multiply the entire equation by 2, and then we would have a 2 here, because 2 times x is 2x. That is some crazy thinking. So I'm going to do that. I'm going to keep my system in order. Okay, I'm going to keep the top equation, 2x plus 3y equals 9. That's the top equation. But now the second equation is going to change. 2 times x is 2x. 2 times 5y. We multiply that 2 by everything. 2 times 5y is 10y. And then 2 times 8. Again, we multiply by everything. 2 times 8 is 16. And now I am in a position where I can cancel these two equations, or I can subtract these two equations and cancel my x. Let's see how fast that works. I'm going to subtract these two equations, and my x cancels completely. 3 minus 10 is negative 7. 9 minus 16 is also negative 7. Clean up the mess, and then solve for y. This actually looks like the last example, doesn't it? Because it is. Once I have my y value, I can use one of the original equations. I'm going to use this original equation because I can. Here's an original equation, but I know y equals 1. I'm going to substitute that value. And now I'm going to solve for x. See how fun this can be? A lot of steps, a lot of thinking. I enjoy thinking. So now I know x is 3, my ordered pair. X is 3, y is 1. I had to think about a number I could multiply by to cancel. So if something doesn't cancel right away, you can multiply an entire equation by a number that would allow that to happen, and then you're able to eliminate. And that's how we solve systems of equations. When we meet again, we're going to talk about word problems and how that operates. But in the meantime, I wish you luck for this. And if you have any questions on anything you just saw, please email me, and I will gladly get back to you. Thank you.